Chain, check and adjustment. In this instructional film, you will see a check and adjustment of the chain carried out. This operation is described in Volume 2, Section 906 of the Maintenance Manual. Always use the instruction manual from the engine in question, as details, for instance data, may differ from engine to engine. During operation, the chain will be slightly elongated, resulting in a slack. This slack can be eliminated by retightening of the chain. If elongation of more than 1% is found, the worn links must be replaced. Before work may begin, the following safety precautions must be taken. Stop the engine. Close the starting air supply. Block the starting mechanism. Connect the turning gear. Shut off lubrication oil. If the engine has been running, you must wait 20 minutes before beginning work. Then open the crankcase cover on the chain housing and secure it with the pin. Before, the chain was checked for correct tension by turning the engine in such a direction that the chain was slack on the free length, the part of the chain with the greatest distance between two chain wheels. Tension was checked by pulling the chain to and fro by hand at the middle of the free length. Normally, the chain should in this way be able to be moved away from the guide bars corresponding to the length of 1/2 or 1 chain link. Nowadays, however, we recommend that the chain be routinely adjusted at least every 4,000 hours. In the case of new chain installation, contact the supplier for detailed breaking-in instructions. The chain is adjusted in the following manner. Begin by turning the engine in such a direction that the chain is slack on the same side as the chain tightener wheel. This means that the engine is turned in the opposite direction from the one shown earlier. Bend out the locking discs on both the lock nuts on the chain tightener bolt. Loosen the lock nuts and nuts so that the chain tightener bolt is free. Begin with the lower nuts, and then loosen the upper nuts far enough to give sufficient clearance for the tightening. Located on the spring is a plate, giving a measurement which is different for each ship. The same information is written down in the Maintenance Manual, Volume 2, Section 906. Make a note of this measurement. The plate on the engine in this film shows that the spring's free length as new was 188.5 millimeters, and when compressed it was 168 millimeters. The difference between a free and a compressed spring being 20.5 millimeters. It is this measurement which is important. With every future adjustment of the spring, this distance, 20.5 millimeters, must be maintained between the free and the compressed states. When the spring in this film was checked, it was found that the free length was no longer 188.5 millimeters. Instead, it was 187 millimeters. Thus, when the spring is compressed by 20.5 millimeters, its length in the compressed state will be 166.5 millimeters. Tighten the lower nut until the spring has been compressed to the correct length, in this case, 166.5 millimeters. During this tightening, the engine must continuously be turned in such a direction that the slack is on the same side as the chain tightener wheel. The chain tightener bolt will move downwards, and the chain is tightened to the correct tension. The upper nut is now screwed down, while checking that the spring is not compressed further, as this can cause a reduction of the chain tension. Tighten the upper lock nut and secure both nuts with the locking disc. The chain tightener bolt is now to be locked. This is done by additional tightening of the lowermost nut until the thrust disc for the spring bears against the distance tube on the chain tightener bolt. This will cause the spring to be further compressed, but it will not affect the chain tension since the upper nuts have been locked into place. When the thrust disc is in place against the distance tube, the nut must be tightened additionally, as indicated in the instruction manual, section 906. For the K90 engine, the nut is turned approximately 40 degrees more. For each engine type, this distance may vary and must be checked with the instruction manual. Finally, in order to lock the chain tightener bolt, the lower lock nut is tightened, and both nuts are secured with a locking disc. Adjustment of the camshaft. During running, the chain will be worn and elongated. This will cause the camshaft to move out of adjustment. Therefore, regular checks of camshaft adjustment are necessary. If the change in camshaft adjustment does not exceed 2 degrees, it can be compensated for by adjusting the fuel pumps. This operation is described in Volume 2, Section 909 of the Instruction Manual. However, if the change exceeds 2 degrees, the camshaft must be adjusted to ensure correct timing of the engine. The change is measured with the help of the pin gauge. On the K90 engine, 2 degrees is equal to 4.8 millimeters. Adjustment instructions can be found in Volume 2, Section 906. After camshaft adjustment, the engine's maximum and mean effective pressures should be checked. Again, for the safety of those working on the engine, the following procedure must be carried out. Stop the engine. Close the starting air supply. Block the starting mechanism. Connect the turning gear. Shut off lubrication oil. Turn the engine until the marking on the turning wheel indicates that the piston in cylinder number 1 is at top dead center. Unscrew the bolts and remove the protective guards above the coupling flanges nearest the chain transmission. Unscrew the 3 plugs closing the hydraulic tool connections on the coupling flange. Mount the special tool for turning the camshaft and attach a block and tackle. Notice that the tool fits over 2 of the coupling flange bolts. The hydraulic tool is now connected to the coupling flange nearest the chain transmission. Hydraulic oil can be led through channels to the joint between shaft and coupling flange, hereby releasing the connection. Apply pressure to the hydraulic tool until oil trickles out between the shaft and the flange. Oil pressure should be supplied during the complete adjustment. The camshaft can now be adjusted and the adjustment checked with the pin gauge. The gauge is so constructed that when the camshaft is correctly positioned, the points of the gauge fit perfectly into 2 holes. One on the camshaft itself and one on the housing wall. Using the block and tackle, the camshaft is turned until the gauge fits perfectly into the holes. Disconnect the hydraulic tool and move it to the coupling flange on the other side of the chain transmission. Also, move the camshaft turning tool and block and tackle. Repeat the procedure. After the camshafts have been adjusted and the hydraulic tool disconnected, wait at least 15 minutes before refitting the plug screws into the flanges again. Remount the protective guards. After camshaft adjustment, the maximum and mean effective pressure of the engine must be checked, and it is possible that the fuel pumps must be adjusted.